However, if your sample size is less than 30 and the distribution of your data, when you plot the distribution of your data set, it does not follow, it's not approximate to the normal. It's skewed, it's different than the normal, it's not following a normal trend. Then we conduct non-parametric tests. Remember, the z-test and the t-test are both parametric tests. If the sample size is less than 30 and when you plot the distribution and the distribution does not follow a normal trend, a normal distribution, then it is not recommended, it is not suggested to conduct t-test or z-test, because then whatever your decision will be, it won't be the correct decision. So we conduct non-parametric tests. Now we are not discussing non-parametric tests, but almost all the statistical software, they have non-parametric tests, and if you find out that you have a smaller sample size which is not following the normal distribution, then you conduct the non-parametric test. However, if your population size is less than 30, it is totally following a normal distribution, you conduct z-test. If your population size is less than 30 and your sigma or standard deviation is not known, you use sample distribution, or you use sample standard deviation, and you assume it's somehow approximate to the population standard deviation, then you conduct a distribution. So z-test, normal distribution, t-distribution, non-normal distribution, so non-parametric tests. Now, this is the last slide of our today's lecture, and this is very important. The reason I'm stating here, you may or you may not understand it right now, but when we will do the SPSS, you will understand it. And also for all the upcoming lecture, like for the next lecture when we'll do the regression analysis, again, this will come up. So if the significant value, which means whenever you conduct a t-test, now the software gives you a value of t-statistics, and it also gives you a p-value or a significant value. That p-value is the probability. If that probability or p-value is less than your alpha value, which is usually 0.05 or 0.01, if you conducted a t-test using a software, it gives you a p-value or a probability value or a significance value. If this p-value is less than your assumed significance level or alpha value, which is 0.05 or 0.01, then the null hypothesis is rejected in favor of the alternative hypothesis. That is how you interpret your results. Keep this in mind, and then when we'll do the test, you will understand how do we interpret it. So let me close this, and let me open this. Okay. Can you see this the SPSS screen? Okay. So what I did is, for today's exercise, I will discuss 3 different types of t-tests. So for today's exercise, I selected 10 data points from our remember the class height data points. So let me bring this in. See, we have 10 students in a class and the heights are measured this way. I go to analyze, I go to compare means, and I select one sample t-test. What is the one sample t-test? One sample t-test is that I have one variable, which is the height here, and I make one claim. I make a claim that the average height of the student in class is whether 62 or 63 or 64 or 65, and then I conduct a t-test to see if my claim is correct or not, or should it be rejected or should it be accepted. So I selected height as the variable, and then the test value, which is against this I want to conduct the test. Let's say our assumption is that the average height of the students in the class is 65 inches. Options, it gives you an option of selecting your confidence level, 95% or 99% or 90%. Let's keep it 95% for now. And then we say, now what does SPSS gives us? SPSS gives us this statistics, which says if the n is the sample size, which is 10, the mean height which is collected from the sample is 67.95, standard deviation is this, standard error is this. T statistics that it computed is 2.604. Degree of freedom. See now the degree of freedom here is 9, which is 10 minus 1 is 9. Degree of freedom is always sample size minus 1. Significance, two-tailed. This is the number I was talking about. This is the p-value. Just based on t distribution or t statistics, you won't be able to say that whether it should be accepted or rejected, because you don't have that table in front of you in here is to compare. Based on what we compare based on this significant two-tailed value or the p-value. This is also called p-value. Now you see here this p-value is 0.029. Now this 0.029 is less than 0.05, which is our significance level. Okay, so we reject the null hypothesis. A null hypothesis that the average height of the students in class is 65. So we reject null hypothesis in favor of the alternative hypothesis that the average height of students in class is not 65 or is greater than 65. So this p-value or significance value or the p-value 0.029, since this is less than our significance value of 0.05, we reject the null hypothesis in favor of the alternative hypothesis. Okay, let's do it once again. Let's select some other value. So let's select something close to 67.9 and then we'll see what happens. Let's select 68. So our null hypothesis is that the average height of the student in class is 68 inches. Now we are testing this hypothesis. And let's see what results do we get here. So this remains same. You see here it's 0.966. Now this 0.966 is way greater than 0.05, which is our significance level. In that case, we accept our null hypothesis. Our null hypothesis is correct. So we accept the null hypothesis that the average height of men in class is 68 inches. And since we had 68 inches close to 67.95, so our null hypothesis was correct. Clear so far? Everyone? Is it clear? Okay. Let's do one more time. Just to see, just to play with it. Let's say, let's keep this as 68 and let's change our confidence interval here to 99% and then see what happens. No, this was true. Since this was true in 5% as well, so it should be true with the 1%. Let's change this to 65, which was rejected in case of 95% confidence level. So let's see what happens now. So, again, not much difference. Even based on the, this 0.029, now this is greater than our significance level of 0.01, which means we accept the null hypothesis that the average height of man in class is 65 inches. So you see how this makes difference? Okay, let's say confidence level 85%. Let's see what happens. And let's keep our claim as it is. Now, of course, this won't change. This number will not change because this is computed. It's the interpretation that will change. Now, this p-value is 0.03, which is less than your significance level of 0.15, right? Because your confidence level is 85%, so your significance level is 15% or 0.15. Since this value is less than your significance level of 0.15, so we reject the null hypothesis in favor of the alternative hypothesis. Clear so far? How do we conduct this one sample t-test? So where if you select a confidence level, you select your claim or any number, and then whatever significance value or whatever p-value is computed here, you compare that with your significance level. If this p-value is greater than the significance level, then we accept the null hypothesis. If it is smaller, then we reject the null hypothesis. Okay. Now let's do. Let me bring in another set of data, so that we'll do the. Okay. Yes, this is the data set. So what I did is I just selected few values from the speed data set that I discussed with you in the previous classes. And so what we have is here the speed data that we collected, and these are the posted speed limits. These are the speed limits that are posted. So what we do is, okay. So what is your question? Oh, you can't hear me? Okay, can you hear me now? All of you? Okay. So now the reason I brought in this data set is because we have different values here and we can conduct different types of t-tests. So for example, can I have the control back? Okay. So here I'll do the independent sample t-test. Now what this independent sample t-test is, it is that, for example, in this data set, I went to different roadways and I collected the speed data sets. Those roadways had different speed limits. Now I want to see that if between two roadways where the speed limits were different, do the speeds of the vehicles also, or is there a significant difference between the speeds of the vehicles on two different roadways with different posted speed limit? Right? That is what I want to know. Now my claim is, my alternative hypothesis is that there is no difference in the mean speed of the vehicles where the posted speed is 30 miles per hour and where the posted speed limit is 40 miles per hour, which means that the mean speeds of the vehicles on both of these roadways where the posted speed limit was different, the mean speeds are same. So my test variable is speed and my grouping variable